Hello, this is Mark O'Brien from Scalar, and I'd like to demonstrate a common troubleshooting exercise and how easy it is to work with Scalar. But first, I'd like to talk a little bit about our architecture and what makes us different from other solutions on the market. When we went to build Scalar, we knew we wanted something that would work very well at scale and also could return search results very fast, allowing you to get from alerts to answers quickly. One way we differentiate is by virtue of the way that we store data. We looked at our competitors who are all using a keyword index-based solution. What this does is, as the data is coming in, they build and maintain a keyword index, which can then be used at the time of searching to reference where certain words or tokens appear in the data set. This works great for web search. It works great when you need to show the top 10 matches and when you're working with human language corpus, largest documents. This is great for data that doesn't change really fast, but none of these things really match the log management use case. Instead, what we need to be able to do is to work with both real-time data as it comes in, as well as looking back on historical data. We need real-time ingestion so the data is accessible to us as fast as possible for alerting and also tailing and troubleshooting. We want to make sure this performs well at scale. And of course, we're working with machine-generated data. So it's not just English words, for example. It's all kinds of combinations of letters and numbers and characters. This is data with very high cardinality. None of these things are really well suited for a keyword index. So instead, we built our own columnar database specifically for this purpose. The idea is that as we ingest data, we parse it into columns or discrete fields, essentially. These fields get stored together on disk. What we're looking at here in this example is a web server log lines, and I've got all of my IP addresses, dates, actions, etc. So if I want to search specifically on IP address, I'm only going to search that particular data. I don't have to scroll through my entire data set to find an answer. So this is one part of our solution, and this is combined with a massively parallel search solution. Scalar is delivered as a hosted service. We leverage the economies of our scale as a vendor to be able to provide you an incredible amount of compute power when it comes time for you to do a search. Your data is sharded among multiple servers, and all of those servers participate in returning search results. We're able to provide you a huge amount of computing power at a very cost-effective rate because these servers are shared amongst all of our customers. We're able to search upwards of 1.5 terabytes of data per second, so we can get you to your answers you need very quickly. What we're looking at here is an overview as you enter a sample Scalar account. We've got a simple e-commerce application here running with some app servers, some image servers, and some web servers. You can see we've got 23 hosts and 61 logs. We're ingesting about 670 million log lines each month. So this is an account with a fair amount of scale. Just want to give you that frame of reference as we move through and you see how fast and how responsive the system is. We've got a very robust alerting system that allows you to set triggers, and we can send alerts either via email, Slack, PagerDuty, OpsGenie, etc. We also have a webhook integration for other systems. But let's say I'm concerned about my response time. I've got an alert here that's set to look for pages where the response time is greater than 10 seconds. And if in a 2-minute period I count more than 2 instances of that, I'm going to fire off my alert. From here I can link over and take a look at a graph showing me how often this is happening. And for example, if I want to collaborate, I could go ahead and add an annotation here. I could type in some text and then share this graph with one of my colleagues. I could post it to Slack or I could copy a link to this graph. Let's say another way to come into the tool would be via dashboard. This is a web server dashboard giving me a heads-up display on a number of different attributes around my data. Similarly to the alert, I'm looking at response time over here. I can expand this and see in more detail. Again, I'm seeing these kind of spikes of slow performance. But the beauty of it here is that these graphs are backed by log lines. So I have the ability to very easily flip over and see the log lines that are behind the graph. What I'm looking at here are web server access logs. We've parsed out a number of attributes, and you can see how they appear on the side here. I can look at things like what agents are represented to see if maybe there's a pattern here between the user agents, or I can look at what hosts are involved, and I can look at my time in milliseconds attribute. So I get a sense of the values here. If I click graph values, this takes me back to my view before where I can see the values over time. I could also look at the distribution of these values. So I could see a histogram showing me the performance. So this is showing me that, a lot of my responses are coming in less than 5 milliseconds, but I do have this troubling long tail here, and even some things as slow as 5 or 10 seconds. If I flip back over to the log lines here, you'll see I have the ability to narrow down. And as I narrow down, it builds out a query for me. I can also type a query myself. So if I want to do something like search for all of the response times that are greater than 10 seconds, I can do that. And you'll notice one of the benefits here of the fact that we're not using a keyword search. We actually treat these as numeric values. So we're very fast when doing numeric searches. We search for ranges, etc. We can also do regular expression searches. That's also something that doesn't work well with keyword indexes. So now I've got my query here. I'm looking at my slow performing transactions, and you can see they're kind of happening in bursts here. You'll also notice within these log lines that there are I'm getting a number of pieces of information. Among them, I'm getting a request ID. This request ID is provided by the web application, and it actually is unique to a specific transaction. A lot of applications do this, particularly microservices or e-commerce services that want to make sure you're tracking a transaction from start to finish. If I do a new search for this request ID, what you'll see here is that I get a set of results that are grouped together. So I'm seeing all of the log lines for this particular transaction as it moves from the web server to the app server and back to the web server. And as I'm scanning through here, you'll see that I'm getting this error, invalid cache detected. Well, I wonder what that is. So, let's see how common this particular error is occurring. Is this unique just to this transaction? Is it unique to one server? What's going on? So very easily, if I highlight that text, I get this set of options here. I'm going to go ahead and do a new search for invalid cache detected, and lo and behold, this is happening a lot, and it seems to be happening on the same pattern. It's just about as often as I was seeing those slow search, the slow page responses. And I can do things like I can look and see, is there a particular server host that's involved? And well, yeah, a couple of them more so than others, but it pretty much is happening with all of them. So it's not particularly unique to a server. It's probably something more related to a dashboard, a database, etc. But in any case, you can see that very quickly through just a handful of searches that I've conducted, mostly just using the mouse, I've been able to pivot through my data and get down from this visualization of understanding that I've got these slow transactions and leaping right into this level of detail where I can see a particular error, and I've got a lot to chase down, either for me or for me to share with my colleagues. One way I could share with my colleagues would be to save the search, or I could copy a link to this search and send it off to them. I'm going to show you one other example here of some of the flexibility of our graphing functionality. So another view that I have over here is my response bandwidth. As a clever engineer once said, bandwidth costs money. So you may be wanting to pay attention to your bandwidth and see what your top offenders are. We do offer the ability to do breakdowns. So what this can do is segment your data out and visualize it. So let's say, for example, I want to look at how the bandwidth is being distributed amongst my different URI paths. So I get this really interesting graph here where I've got a number of lines clustered down here and a couple up top here. And if I look more closely, I can see, oh yeah, look, it's my image and image render paths that are utilizing the most bandwidth. Well, I guess that's no big surprise, but maybe that gives me an idea that I might want to implement some kind of compression or some other solution to try and address the low-hanging fruit in terms of reducing my bandwidth. So there are just a couple of examples of how easy it is to navigate through Scalar and to work with it to drive to answers. Thank you so much. I hope this was useful.